do a discrete versus continuous comparison. So we're going to do kind of a side-by-side of what is discrete, what things do I need to understand about working with discrete, and what is continuous, and what things do I need to understand about continuous. So we were just talking about which equations you can use with which type and some other types of names that go with it. So a side-by-side I think will be a nice way to organize that all in your notebook. One type of graph is our discrete graph. The other type is our continuous graph. So discrete, visually, we said, is where the points on the graph are not connected, right? And the reason for that, we said, is by not connecting the points, what we're communicating is that there's nothing happening between here. There are no data values in between the points. Literally, here's a data value, and then there's nothing until we get to here. That's what you're mathematically communicating when you leave the points not connected. So points not connected, what that communicates is that there's no data values between the points on the graph. No data between points. So that's what that means when you leave it not connected. Versus continuous. Continuous was like the swimming pool, right? So this would be the one where we've got the points, but now we're connecting them. This is kind of a side comment. You guys may have noticed on the answer key that there was an arrow there. What does that arrow mean? Yeah, you only did your graph for the first 5 minutes, but it's going to take more than that to fill the pool. So that's a mathematical way of communicating that it keeps going. And this actually gets into some symbols and notations on a graph that we're going to get into more in Module 3, but it doesn't hurt to think ahead, right? So if something keeps going on a graph, especially with a continuous graph, usually we'll put an arrow there to communicate there are more data values that we didn't show. This one, the points are connected. And what that's showing is that I have data in between points. So with the pool problem, this would be 0 minutes, this would be 1 minute, but 30 seconds, the pool's still filling. 45 seconds, the pool's still filling. So there's data in between the values that I'm marking on the graph. That's why I need the line to kind of catch all those in between points. So the points are connected because there is data in between the points that are marked. That's what that means. The other thing, and why I thought it would be good to organize this as kind of a side-by-side comparison, I could zoom this in a little bit. Hopefully that helps people in the back of the room. What types of equations can I use for discrete? Both of them. Yeah. So I can use a recursive or an explicit equation. What types of equations work for continuous? Yeah, just explicit. And again, we said the problem with recursive is recursive looks back at a previous data value. But when you do that with continuous, looking back at the previous data value is going to skip over all these in-between things. So we're kind of ignoring them, which is why a recursive equation is not a good idea if you have something continuous. So if you have something continuous, then we're just going to say explicit equation is going to be your best bet. This is both a good thing and a bad thing. It's kind of a good thing because it's less work to only write one equation. The downside is that for a lot of people, I know recursive equations are a little bit easier to see and write. Recursive equations are, explicit equations could be trickier to come up with. So this is kind of pushing you a little bit to make sure you have your explicit equations under control, because something continuous, that's really your only option. We're taking away the recursive equation there because it doesn't fit with what's happening in the problem. The other thing that we said too is we introduced some vocabulary, and I'm going to kind of put this side by side. So here's kind of our compare and contrast with the graph, with the equation. And then we said vocabulary, this we would call an arithmetic sequence. Again, sequences are discrete. So I don't want to call this a sequence. Instead, I would call this a function. And the arithmetic is going to get replaced with what's happening on the graph. So we're going to call this a linear function. Both of them follow the same pattern. The only difference really boils down to, is it discrete or is it continuous? So we're just giving some different vocabulary to help tell them apart when we don't have the graph to look at. We're going to add one more vocab thing in here, but I want to look at the last couple of problems first, and then we'll add that in.